Hi everyone, in our lesson today we'll do an introduction to simplifying radicals. First, a perfect square is a number that can be expressed as the product of two identical factors. For example, 4 is a perfect square since it can be written as 2 times 2. I'm going to take a minute and complete this table by squaring each of the numbers in the first row. So 2 squared, as we said, is 4. 3 squared is 9. 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay, of course, the perfect squares continue going on forever, but in this particular case, the numbers get pretty big pretty quickly, so this is what we need for now. All right, in our first 4 questions, we're taking and simplifying perfect squares. So for example, the square root of 9 would just be 3, because 9 can be written as 3 times 3. We see 3 as a factor twice, so we're going to write our final answer just as 3. No radical sign anymore. You took the square root of 9, and the result was 3. The square root of 25 could be written as 5 times 5. So the square root of 25, we'll say, is just 5. The square root of 81 could be written as 9 times 9. So the square root of 81 is just 9. And finally, the square root of 121 could be written as the square root of 11 times 11. We use 11 as a factor twice. So 11 is the square root of 121. From now on, if you have a perfect square, you don't have to break it down into a product of its factors. In the next group, we have to simplify these radicals, meaning our answer is going to have a number in front of the square root sign and a number inside the radical. All right, no decimals for answers, starting with this row. So for example, I gave you the square root of 32. 32, while it's divisible by 4, we want to go for the greatest perfect square that divides into it, which happens to be 16. 16 times 2 is 32, but the square root of 16 gives us this 4 out in front. That 2 is left over inside the radical. So that's why I say we have a number in front, and then we have a number inside the radical. Okay, and number 5, we'll factor 12 into 4 times 3. So notice that I've written the radical, square root, right? And then I wrote 4 times 3 inside. Now, I'm in the habit of circling the number that's the perfect square, so you know that that's what we're going to take the square root of. Square root of 4 is 2, and we're left with a 3 inside the radical. So final answer is 2 square root of 3. In example number 6, we have the square root of 75. If I start to take a look at my list, I notice that 4, 9, and 16 don't divide evenly into 75, but 25 does. So we're going to rewrite the square root of 75 as the square root of 25 times 3. Take the square root of 25, and we get 5, and we're left with the 3 inside the square root. So 5 square root of 3 is simplest radical form for that one. All right, with the square root of 24, again, I go to my list of perfect squares, starting with 4, and I try to find which one divides into it. So 24 is divisible by 4. It's not divisible evenly by 9 or 16. And then 25 gets too big, so we want to use our 4. To rewrite the square root of 24 as the square root of 4 times 6. Nice little color change there. All right, square root of 4 gives us 2 out in front, and we're left with a 6 inside the square root. All right, with the last one in this group, the square root of 125. Now, the fact that there's a 25 in there is kind of a little bit of a heads up for me. So 25 does divide into 125 5 times. Think if you had $1.25, you'd have 5 quarters. or 5 times 25. Take the square root of 25 to get a 5 out in front of the radical, and we have a 5 left over inside the radical. Okay, in our next group of problems, we already have a number out in front of the square root sign. So what we do is we multiply that number, in this example, the 3, by whatever else we bring out of the radical. So factor 12 into 4 times 3, 4 being the perfect square. So the 3 that's out in front gets multiplied by the square root of 4, which happens to be 2. And 3 times 2 gives us 6 square root of 3. So number 9, we have kind of an easy one here. It's 8 times the square root of 16. Well, 16 itself is a perfect square. So the square root of 16 is 4. So our final answer is going to be 8 times 4, or 32. Okay, number 10 is a little more like the example. We have to simplify. So 8 is not a perfect square, but it is divisible by 4. So we have our 5 out in front. That 5 will get multiplied by the result of taking the square root of 4. Square root of 4 is 2, and we're left with a 2 inside the square root sign. So our final answer will be 10 square root of 2. All right, for the last 3 problems, we're going to be multiplying radicals. So when we have the square root of 3 times the square root of 8, you're going to multiply the 3 and the 8 to get 24, and now you've created something that now has to be simplified. So the perfect square that divides into 24, the largest perfect square that divides into 24 is 4. We write it as 4 times 6. The square root of 4 gives us a 2 out in front, and this 6 stays inside the square root. So for number 11, the square root of 2 times the square root of 6 will become the square root of 12. And then we want to factor that into 4 times 3. This 4 is the perfect square that divides into 12. The square root of 4 gives us 2, and we're left with that 3 inside the radical. All right, 2 more. Number 12, we have the square root of 6 times the square root of 3. You can think of it as the square root of 6 times 3, which is 18. Now, 18 is not evenly divisible by 4, but it is evenly divisible by the next perfect square on our list, which is 9. So 9 times 2 is 18. Take the square root of that 9 to get 3, and we're left with a 2 inside the radical. Okay, number 13. When we have numbers out in front, we multiply them together. So we want to do 3 times 4. And then the numbers inside the radical get multiplied. So this one's going to look a little bit funny because we're going to have 12 square root of 12. But this 12 that's inside the square root, that's got to be simplified. So the square root of 12 factors into 4 times 3. So we have this 12. Take the square root of 4 to get 2. We're left with that 3 inside the radical. That 3 stays there. Final answer, take 12 times 2 to get 24 square root of 3. All right, and that's it for today's lesson on radicals. So just make sure you give the practice a try.